we start with the quiz, a couple of problems. I want to know what the decimal equivalent is. And then the third problem, what are the more involved problems that you had on the, or similar to some of the more problems that you had on the homework, okay? So let's just start here with 2 times 10 to the third. Now this is new. That actually, what this is scientific notation. Now some of you actually worked ahead a little bit and have done the scientific notation, which is no big deal. So let's see how that works out if we use scientific notation. Now, there are a lot of ways you can do this. I didn't say which way, so any way you did it is good. But I want to use this to motivate scientific notation. We have 2 times 10 to the third multiplied by 7 times 10 to the negative 7th. Well, that equals 2 times 7, because this is just a series of multiplications here, right? We do them in any order. And 2 times 7 is easy, that's going to be 14. And then we have times 10 to the third times 10 to the negative 7th. And we're going to do the numbers here, plain old numbers without exponents. We're going to get 14. And 10 to the third times 10 to the 7th, you know, from the homework you did last night and from what we did in class last time, that's a multiplication. We're just going to add the exponents. That's 3 plus negative 7. We just write that as 3 minus 7. But we get, so what we have, 2 times 10 to the third multiplied by 7 times 10 to the negative 7th is 2 times 7 multiplied by 10 to the third times 10 to the negative 7th. We multiply the 2 by the 7 to get 14. We multiply 10 to the third times 10 to the negative 7th to get 10 to the 3 minus 7. Turns out that's 14 times 10 to the minus 4th. Now, we could move the decimal in the 14 over 4 places and get 0.0014. It'd be a perfectly good answer. It's one that we can kind of relate to. But what we do is we make the convention that our first number has to be between 1 and 10, not including 10. It can't be 10. It can be 1, but it can't be 10. And then this number is whatever power you end up with when you do that. Now let's see what I mean by that. 14 can be written as 1.4 times 10. So I take 14 and write it as 1.4 times 10, okay? And then 10 times 10 to the negative 4th, it helps to remind ourselves that 10 is just 10 to the 1. Just helps avoid confusion. It's unnecessary if you're careful. But okay, so this is 14, or so 1.4 now, times 10 to the 1 minus 4. Because 10 to the 1 times 10 to the negative 4 is 10 to the 1 minus 4, which is 1.4 times 10 to the negative third. Okay? So what you learn to do in the section on scientific notation is just do this sort of thing. There's nothing in there that you don't understand. If it's new to you, you have to sort it out a little bit, and we'll do a couple of problems to begin doing that. The advantage is that you never have to write a number like 2,000 times 0.000007. We wrote, there are as many zeros in this as there are in pretty much the rest of the calculation, okay? And do you really understand the number like 0.000007? Well, if it had a length of 0.000007 meters, that would be 700 nanometers, or 7/10 of a micron. It's a little smaller than a small bacterium, maybe a little bigger than the average virus. So I know that. You don't think in those terms, probably. Your field doesn't take you in those terms, but there are plenty of places where you have numbers like this that really don't make sense. When you see this number, you can get a feel for 10 to the third, 10 to the negative fourth, 10 to the negative seventh. And even if you don't have a feel for it, you can see it right there in front of you. Okay. So one of the benefits of this is that you can do this calculation without having to multiply these out and keep track of all the zeros. And that's kind of a bottom line. And then you end up with a number that's not that hard to understand. It's 0.0014. Plenty of benefit to it, depending on what it is you happen to be studying. Okay, now, I haven't left myself a lot of room to do 3 times 10 to the 8th times 50,000. We're going to try to squeeze it in here. Okay. I'm going to write that as 3 times 10 to the 8th multiplied by 5 times 10 to the 4th. Okay. Why is it 10 to the 4th? Well, just think your decimals here. If you move it over 1, 2, 3, 4 places, that's going to give you the 10 to the 4th. And I'm not going to go into a lot of explanation of that. You're going to see a little more explanation in open math. But that's another thing that's pretty easy. Okay. If you see 0.000007, and I think I said too many zeros, but you just count through the decimal 1, 2, 3, 4, 5, 6, 7 places to the right, that's going to be like 10 to the multiplying by 10 to the negative 7th. You just take the number you got here, multiply by 10 to the negative 7. Okay, so that's a rule I don't think you'll have any trouble with. Open math will explain that perfectly well. Okay. So again, 50,000 is 5 times 10 to the 4th. It doesn't hurt to check that out. What's 10 to the 4th? You got 10, multiply by another 10 gives you 0, multiply by another 10 gives you 0, multiply by another 10 gives you another 0. There's a way to look at it. Little note there. Again, what I've seen, that will be hard for you to understand. Okay, anyhow, then this is going to become 3 times 5 multiplied by 10 to the 8th times 10 to the 4th. That's 15 times 10 to the 8th plus 4. 10 to the 8th plus 4 is 10 to the 12th. 15 is 1.5 times 10. Make that 10 to the 1, and we see that what we get is 1.5 times 10 to the 12 plus 1 equals 1.5 times 10 to the 13th. Okay? 15 trillion. That's dollars. That's about a quarter of the U.S. economy. I think I don't pay much attention. It's in the tens of trillions, several tens of trillions. Okay, again, nothing that I expect is going to give you trouble. If I find that it does, we'll talk more about it. Okay. Probably quiz you on it next time. All right, now let's look at this thing. Write it out again. Now, this is just a matter of knowing the rules and being careful. Also kind of knowing what to do first. Okay. Well, I'd start by simplifying what's in each set of parentheses. At least what's in this set of parentheses. I'm cubing this. So this is going to be 2 squared cubed times x squared cubed times y cubed over 3 squared cubed times z to the negative 3 cubed. And I'm going to leave this one alone for the moment. There's no exponent outside of here. And right now I'm dealing with, raising the first factor to the third power. And we got a little simplification to do here before we can start articulating it with the other factors. So 2 squared cubed, I'm going to write it out in detail. That's 2 to the 2 times 3 times x to the 2 times 3 times y to the 3 times 3. Because, of course, when we raise a power to a power, we multiply the powers. For the reasons we saw last time, and you want to always be aware of the reasons. And I do recommend that you write out the reasons. You can write these out, at least a few of them, in all their gory detail like we did last time, okay? But here's what it comes down to. Now 3 squared cubed is 3 to the 2 times 3, and z to the negative 3 cubed is z to the negative 3 times 3. Still not doing anything with this. It's the term on the right. Okay. Now, again, going along with the term on the left, 2 to the 2 times 3 is 2 to the 6th. X to the 2 times 3 is x to the 6th. Y to the 3 times 3 is y to the 9th. 3 to the 2 times 3 is 3 to the 6th. Z to the negative 3 times 3 is z to the negative 9th. Now we multiply out, we write out the second factor, 5 squared x to the negative 3, y to the 4th, over 7 squared x, z to the negative 4th. And what are we going to do now? Well, this is two fractions, essentially. You can multiply the numerators and multiply the denominators. Somebody's got a question, which usually means that I did something bonehead. Okay, I fell into a pattern, multiplying everything by 3. This is only y to the third. It's not y to the third raised to the third. So this should just be a y to the third. Okay, so in the third step where I have 2 to the 2 times 3, x to the 2 times 3, y to the 3 times 3, why should it just been y to the third? Because originally, your original numerator was 2 squared x squared y in the factor that was raised to the third power. There's just a y there. So there's just a y to the third here. And there'll just be a y to the third all the way down on that first factor. Okay. Okay, so now multiplying fractions by fractions, we understand we multiply numerator by numerator, denominator by denominator. And when I multiply the numerator by the numerator, I'm going to multiply it in the order that we generally prefer. We have 2 to the 6 times 5 squared. That's part of what we get when we multiply these numerators. So I can write my 2 to the 6th times 5 squared. And then I can write my x to the 6 times x to the negative 3. And my y to the third, not y to the ninth, y to the third times y to the fourth. In the denominator, I can take my numbers 3 to the 6th and 7 squared. 3 to 6 times 7 squared. And then it's going to be z to the negative 9th x z to the negative 4th. Okay. Now, when you get practiced with expressions like this, there are things you can shortcut. You can pretty much go, you could say x to the 6th times x to the negative third is x to the third, right? X to the 6 minus 3. You could skip directly from this down a couple of steps and probably get it right. But first, practice it and write out every step so you know what you're skipping. Okay, so I'm going to write that whole thing real quickly. Keep track of what we're doing. Okay, here it is again at the top of the board. 2 to the 6 times 5 squared times x to the 6 times x to the negative third times y to the third times y to the fourth. And 3 to the 6 times 7 squared, z to the negative ninth, z to the negative fourth, and there's an x in there that I didn't write. Fortunately, I left myself a little bit of room to write it. Okay. So there's also an x in the denominator that I just added in. Now I've got things arranged to where it's pretty easy to see what to do. I'm going to just keep my 2 to the 6th and 5 squared there. My x to the 6 times x to the negative third will be x to the 6 minus 3. Y to the third times y to the fourth is y to the 3 plus 4. Denominator, we'll keep the 3 to the 6th and 7 squared. Z to the negative ninth times z to the negative fourth is z to the negative 9 minus 4. And we have an x. Okay, that's a pretty straightforward step. Everybody okay with that? Okay. Now the next step is, very easy. We just do 6 minus 5, x to the 6 minus, it's 6 minus 3. My 3 looks like a 5. X to the 6 minus 3 is x to the third. So 6 minus 3 is 3. Y to the 3 plus 4 is y to the 7th. 3 to the 6th and 7 squared are still there. Z to the negative 9 minus 4 is z to the negative 13th. Then we have x. Now, do we have anything any factors of the numerator that are common to factors of the denominator? Well, we have an x cubed in the numerator and an x in the denominator. X is a common factor. That means you can cancel x, but I'm not going to. Okay? When you cancel x, you just cross all the x's out? No. You divide x into x cubed. That's what you're doing. You divide x into x cubed and you get x squared. Okay? And I don't cross anything out. I just call that x squared. You can do what you wish with a term like that. As long as it's correct, I'm okay with it. But don't make errors in canceling. I can easily write out the same expression, bringing my x cubed off all the way to the right and my x in the denominator all the way to the right. So the x in the numerator comes out to the right, the x in the denominator comes out to the right, and I actually make another fraction out of x cubed over x. Now, clearly, the numerator is still going to be the same. I still have 2 to the 6th, 5 squared, y to the 7th, and x cubed in the numerator. What if I was to multiply these? And I would still have 3 to the 6th times 7 squared times z to the negative 13th times x in the denominator. But of course, x cubed over x gives you x squared. So I have 2 to the 6th, 5 squared, y to the 7th, over 3 to the 6th, 7 squared, z to the negative 13th. And I'll just say that's times x squared over 1. That's probably overdoing it. And then I can multiply my numerators and denominators and get 2 to the 6th times 5 squared times y to the 7th times x squared over 3 to the 6th times 7 squared times z to the negative 13th. Now, there are no common factors in the numerator and the denominator. One thing, though, that we don't like to see, really don't like to see a negative exponent in the denominator. Okay? I'm just going to say, well, that's 2 to the 6th times 5 squared times y to the 7th times x squared times z to the 13th over 3 to the 6th times 7 squared. Z to the negative 13th in the denominator is the same as z to the 13th in the numerator. Why is that? Because well, I'm not going to go into the detail of why that is. Something with a negative exponent in the denominator will have the positive of that exponent in the numerator. Okay? And if you got a negative exponent in the numerator, it could become a positive exponent in the denominator. That's a rule. There's a reason for it. I could trace it back, but I've already traced out a pretty big chunk of detail on this problem. So I'm going to leave that one. And if it becomes an issue, we'll talk about it later. Comes down to complex fractions. You could write this as z to the negative 13th is a 1 over z to the 13th in the denominator. When you divide by a fraction, you multiply by the reciprocal, and there it is. But you don't want to do that right now. Okay. Maybe you want to know that. You don't want to have to deal with it. All the rest of this stuff. All right. there's a little more. This would be the expression with no negative exponents. Okay. There's one more way we could write it. The 3 to the 6th and the 7 squared in the denominator could be written as 3 to the negative 6, 7 to the negative 2 in the numerator. I'm not sure how much you were asked to do in this assignment, but sometimes you're asked to express an expression, to express to write an algebraic expression with no denominator. Okay, this is your no denominators form. 2 to the 6th times 5 squared, 3 to the negative 6, 7 squared, y to the 7th, x squared, z to the 13th. The original expression, my final expression, was one with no negative exponents. I had a negative exponent in the denominator. Brought it up into the numerator. Okay. And sometimes you want to see it one way, sometimes you want to see it another way. Sometimes you don't want to be looking at a negative exponent. Sometimes you don't want to be looking at denominator. Fractions can be confusing. All right. So that's it. I'm going to kind of let you loose on scientific notation because my experience is it doesn't give people much trouble. Okay. And I want to move on to a topic that's actually kind of neat. Also kind of makes you wonder if you're not aware of what it's good for, of why are we doing this? What good is this? I'll try to give you a little insight on that too. Okay. First of all, can you multiply x minus 3 times x plus 5? Just jot on your paper what you think you get if you multiply x minus 3 times x plus 5. Okay. The big point here is that the x here is going to multiply this x, it's going to multiply the 5. Okay. In other words, the x is part of what multiplies x plus 5. So x is going to have to multiply x, and x is going to have to multiply 5. And the negative 3 is multiplied by the x plus 5. So it's multiplied by the x, and it's multiplied by the 5. And we write that out as this equals x times x plus 5 minus 3 times x plus 5. Okay, does that halfway make sense? That's a rule. And it makes a certain amount of sense because, again, this whole expression in parentheses, the x minus 3, is multiplied by the x plus 5. So the x must be multiplied by the x plus 5, and the negative 3 must be multiplied by the x plus 5. Now, how do we multiply x by x plus 5? Well, we multiply x by x, and we multiply x by 5. So we get x times x plus x times 5. And then minus 3 times the quantity x plus 5. Well, we're going to multiply not minus 3 times x plus negative 3 times 5. Then x times x is x squared. X times 5 is 5x. Negative 3 times x is negative 3x. And negative 3 times 5 is negative 15. So we have plus a negative 15. And of course, that just means minus 15. Then the x squared is already taken care of. We have 5x and minus 3x. We can combine those. 5x and minus 3x is, as you would expect, 2x. Since 5 minus 3 is 2. If we got 5 of them and 3 of them, we've got, and if we got 5 of them, take away 3 of them, we got 2 of them. Okay? So it's this. Step by step. If you didn't already know that, make sure you do. Some of you got it, some of you didn't. But that's an important rule. Now, I want to check one thing here to see a little more specifically what I need to be telling you right now for your homework. Okay, let's take a problem like this now. I want to add 5x cubed minus 3x squared plus 2x minus 7 to 2x to the fourth plus 6x squared plus 5x. Now, the rule is you can only combine like powers. You can't add a multiple of x cubed to a multiple of x to the fourth. Okay? Reason for that is x represents, well, x is a variable. It could represent any number. Since the value of x is always changing, it follows, and I don't want to go through the details right now, but we will next time if there's any confusion on it. It follows that if like 5x cubed plus 2x to the fourth equals 7x to the seventh or something like that, that might be true for one value of x, but it won't be true for the others. So you want something that's true for all values of x, and that's why you can't combine like powers. And that's kind of worth thinking about, kind of worth knowing. But the bottom line is you don't combine unlike powers. So what you can say is, okay, let's see. What's the highest power term? You usually look for the highest power term. Okay. Highest power is the fourth power, right? So we have a plus 2x to the fourth, so we can write a 2x to the fourth. That's going to be part of your sum. There are no other x to the fourth terms. So that's the only one we've got. That's what we start with. Then we look for x cubed terms. Well, there are no x cubed terms over here on the 2x to the fourth plus 6x squared plus 5x. But there's a 5x cubed term right here in the first polynomial. And that's the only one we've got, so we know that we're going to have 5x cubed. Okay? Now let's look at x squared terms. Let's see. Well, we've got a negative 3x squared in the first polynomial and a plus 6x squared in the second polynomial. So we want to write those together. Now, I'm not going to combine them just yet. I'm just going to write out, okay, got negative 3x squared plus 6x squared. Those have the same power, so we're going to be able to combine them in the next step. Negative 3x squared and 6x squared gives us 3x squared. Okay. Okay, so we have x squared terms. Now we have x terms. Okay, well, we have 2x and we have 5x. So we're going to write plus 2x plus 5x. And then we have the number negative 7, and there's no number on the end of the second polynomial, so we just write down our minus 7. So all we've done now is we've written out all the terms in both polynomials, but we put all the x to the fourth terms together, x cubed terms, x squared terms, and we've done them in decreasing order of the exponent. So this is not a difficult process. You just got to do everything I said, which is simply don't combine unlike terms. Okay? Write them out in order like this, highest power down to lowest. Well, then that gives us 2x to the fourth plus 5x cubed. Then we have minus 3x squared plus 6x squared. That's just plain old plus 3x squared. And then 2x and 5x is 7x minus 7. That's relatively painless. Okay, I have to give myself a little more room, but I'm going to give you one to work on. Okay, I'm going to do okay. 7x to the sixth minus 5x to the fourth plus 6x squared plus 4. Add that to 3x cubed minus 5x to the fifth plus 7x squared plus 9. Try to write out every step. Okay, now everybody did pretty well with this. We begin by looking for the highest power term, which is the sixth power. Sometimes open math, or maybe even me on a test, will throw one at you where the highest power isn't the first term. Get the powers in different, out of order. Yeah, then you want to put them in order just to get things organized, okay? Sometimes you have to do that. But right now we just look for the highest power. We look over the whole thing. The highest power is the sixth power. We've got that twice. We've got a 7x to the sixth in the first polynomial and a 3x to the sixth in the second one. Then what's the next power? X to the fifth. There's no x to the fifth in the first one, but right there in the second one, there's a minus 5. X to the fifth. And we look for fourth powers. Well, we got a minus 5x to the fourth in the first term, so let's write that, minus 5x to the fourth. But there's no x to the fourth term in the second polynomial, so we're done there. Now we've got a 6x squared in the first polynomial. Okay, we don't have any x cubed. We look for x cubed terms, but there are no x cubed terms. So we go to x squared. We got a 6x squared term in the first polynomial and a 7x squared term in the second polynomial. And we don't have any x terms either. But we have a 4 and a 9, so we'll put the 4 and the 9 next. And we have 7x to the 6th plus 3x to the 6th minus 5x to the 5th minus 5x to the 4th plus 6x squared plus 7x squared plus 4 plus 9. Then 7x to the 6th plus 3x to the 6th. You got 7 of them, you got 3 of them, you got 10 of them. That's 10x to the 6th. You have minus 5x to the 5th, and that's it. Now, I was intending that this might look a little confusing, minus 5x to the 5th, minus 5x to the 4th. There are a lot of 5s there. That'll fool your eye if you're like me, okay? And you want to look at it very carefully and notice that these are unlike terms, okay? You might want to do something like minus 5, but you can't because this minus 5 is on an x to the 5th. This minus 5 is on an x to the 4th. Okay, so you have your minus 5x to the 5th, then you have your minus 5x to the 4th. They don't combine even though your eye kind of catches something there. And maybe it looks like they ought to, but they don't. Because the rule is they have different powers. They're not combined. Okay, 6x squared and 7x squared. Well, we got 6 of them, we got 7 of them, that makes 13. 13 what? 13x squared. And then 4 and 9 add up to 13, and we're done. Okay, everybody agree? And I could have made a mistake, and I make mistakes. Okay, I'm going to give you another little bit of a curveball here. We have is 3x to the 4th plus 2x cubed minus 7x squared plus 5x minus 4 minus 2x squared multiplied by the quantity 2x to the 4th plus 5x squared minus 3x squared minus 4x plus 3. And I wrote 5x squared there. It should be 5x cubed. So again, it's minus the quantity 2x squared times the quantity minus 2x squared times the quantity 2x to the 4th plus 5x cubed minus 3x squared minus 4x plus 3. Let's see what you do with that. It's not difficult, but if you're not sure what to do, you might need me to tell you, okay? See what you do with it for a couple of minutes. And if you don't understand it right now, you will within 5 minutes. Okay, the first thing we have to see here is we got this minus 2x squared multiplied by this whole 2x to the 4th plus 5x cubed minus 3x squared minus 4x plus 3. Okay? So we're going to have to do something about that. We can't combine these until we've just got a polynomial and a polynomial. So let's go ahead and write the whole thing out. 3x to the 4th plus 2x cubed minus 7x squared plus 5x minus 4. And then it's going to be what? Well, the minus 2x squared is multiplied by the entire second polynomial, so it distributes. So it's going to multiply every term of the polynomial. So we're going to have minus 2x squared times 2x to the 4th. And our next term in the polynomial is 5x cubed, so the negative 2x squared is going to multiply it. We have negative 2x squared times 5x cubed. And then we have negative 3x squared in our second polynomial. That's multiplied by the negative 2x squared. So we have negative 2x squared times negative 3x squared. We're going to run out of room here. Then minus 2x squared times that negative 4x. And I'm out of room, but I'll just slip the minus 2x squared times 3 in there, so that the minus 2x squared has multiplied everything, every term in the second polynomial. So one thing that happens is you get into one of these things and you're worried about what's going to happen 3 steps later. So you get paralyzed. You don't see 3 steps ahead. Now, after you've done some of these, you probably will. Right now, all you got to do is one rule at a time. Okay? We do the distributive law because you're not going to go anywhere until you do that. Okay. Well, now it becomes somewhat easier now because it isn't difficult to multiply these terms out. I'm multiplying right in my first polynomial, 3x to the 4th plus 2x squared minus 7x squared plus 5x minus 4. And then minus 2x squared times a quantity 2x to the 4th. Well, I'm not going to take the time right now to say 2 times 2 multiplied by x squared times x to the 4th. We know to do that. Okay, 2 times 2 is 4. First of all, we have a minus sign. Okay, we have a minus 2x squared times a 2x to the 4th. There's just one minus sign there. So we're going to write a minus sign. 2 times 2 is 4. And x squared times x to the 4th is x to the 6th. You got to be careful now. You're multiplying, and since you're multiplying a lot of stuff, you're going to want to multiply the 2 by the 4. The x squared times x to the 4th, you're going to multiply those exponents. Something in you is going to have an impulse to multiply those exponents, and you got to have a little bit of a filter there. Okay? You got to be careful that you're multiplying things with exponents. You got to add the exponents. Okay. Then we have minus 2x squared times a quantity 5x third. We're going to have a minus again. 2 times 5 is 10. X squared times x to the third is x to the 2 plus 3, which is x to the 5th. Now, I've been writing out the step x to the 2 plus 3, and you should when you're first working these. Okay, don't skip that step. But right now, we're not exactly pressed for time. We got about 6 minutes left. That's going to be plenty of time to finish this, but I don't want to push it. Okay, so we have next term is minus 2x squared times minus 3x squared. That's a minus times a minus, which is going to give us a plus. 2 times 3 is 6. X squared times x squared is x to the 2 plus 2, which is x to the 4th. Okay, then we have minus 2x squared times minus 4x. Again, 2 negatives makes a positive. We have plus 8. 2 times 4 is 8. X squared times x is x to the 2 plus 1. X squared times x to the 1 is x to the 2 plus 1, which is x to the third. Minus 2x squared times 3, well, that's just minus 6x squared. So that's really kind of easy, but you really got to be careful. Okay. Now let's see what we've got. We've got our 3x to the 4th plus 2x cubed minus 7x squared plus 5x minus 4, minus 4x to the 6th minus 10x to the 5th plus 6x to the 4th plus 8x cubed minus 6x squared. Looking at that, I see that I've got an x to the 6th and an x to the 5th term in from my second polynomial. The first term, the leading term in the first polynomial is a 3x to the 4th. So I'm going to write out my x to the 6th, x to the 5th terms first. So I'm going to have my minus 4x to the 6th minus 10x to the fifth. Okay, then we have x to the fourth terms. We have an x to the fourth term in the first polynomial, 3x to the fourth, and a 6x to the fourth in the second. That gives us plus, and I'm going to write that out, 3x to the fourth plus 6x to the fourth. I really want to see every term down here. I want to be able to look back and make sure I've got every term, because it's really easy to mess something up. And if you don't have it written out like this, it's going to be really hard to find. Okay? Okay, then minus or plus 2x cubed and 8x cubed. I've got a 2x cubed in the first polynomial, and then 8x cubed in the second polynomial. Then minus 7x squared minus 6x squared. Well, minus 7 and minus 6, well, let's write it out. Minus 7x squared minus 6x squared. Okay? Now, I don't have any more terms in the second polynomial. Everything has at least an x squared. Why is that? Well, second polynomial came from multiplying a negative 2x squared by a polynomial. So you're going to have at least an x squared in every term. So we're done with the x squareds in the second polynomial. And now we have a 5x minus 4 in the first polynomial. And there we have everything. We could even make check marks. Okay, we have minus 4x to the sixth here. We have minus 4x to the sixth here. Check those off. We have a 10x to the fifth somewhere here and here. And in our new polynomial, we have a 3x to the fourth, and find that in the original polynomial, 3x to the fourth. Check it off. Check off the 6x to the fourth. Check off the 2x cubed. Check off the 8x squared. Check off the negative 7x squared. Check off the 6x, negative 6x squared. Check off the 5x. Check off the negative 4. It only takes a minute to check these things off. And then you check and make sure everything has a check mark in both steps. Then you're safe to go on. Because if you make a mistake somewhere, you want to get it right, you got to kind of start all over. Check at every step. Okay, you're still going to make mistakes, but you're not going to make as many, and they're going to be easier to find if you're very systematic. Okay, so we have negative 4x to the sixth. It's only x to the sixth. We have negative 10x to the fifth. No other x to the fifths. We have 3x to the fourth and 6x to the fourth, which is 9x to the fourth. We have 2x cubed and 8x cubed, which is 10x cubed. We have negative 7x squared minus 6x squared. That's minus 13x squared. And then we have our 5x and our minus 4. Now all we have to do is sketch a graph of this thing. Now we're not going to do that. Okay. That's something that you have a lot of fun with about this time in a pre-calculus course. And that involves, we got to build up the intermediate algebras before you're in a position to do that. So anyhow, there it is. And there are tricks you can learn to give you the shape of this graph. Now you might wonder, why does anybody care about the shape of this graph? Okay. And sometimes there isn't a real good answer to that. But that's because the answer comes later in a higher level course and you wouldn't understand it yet. Okay. And of course, there are a lot of applications I don't understand, I'm not aware of. All right. Think we're good. The assignments for next time are the scientific notation, which I think you'll find straightforward. And then the polynomials, and if you're able to do what we just did, I don't think you'll have much trouble with it. Just be careful.